Alright, so this time we're going to go through and we're going to do a real quick basic review of how to solve a system of equations. Up at the top here, I have the three ways that you guys should be familiar with already: substitution, elimination, and graphing. And then a fourth method that we're going to get into in the next day or two is solving it with a matrix. So if we look at our first system here, we've got a 2 by 2. So we're going to be able to solve it with either of these three methods, and you just kind of look and see which one would be the easiest to use. And if you already have one variable by itself with no coefficients in front, substitution is going to be the quickest way. But in order to substitute, you have to get one of the variables completely isolated. So we would add 6x to both sides, so that means the second equation is really negative 11 plus 6x. That tells me that y and negative 11 plus 6x are the exact same thing. So you can take that and substitute it in wherever you see a y in the opposite equation. You can't plug it to the original because it's not going to help us out. So if we do that, that becomes negative 2x minus 3, and instead of y, I'm going to plug in negative 11 plus 6x equal to negative 7. And then from here it's a linear equation. Negative 3 times negative 11 is positive 33. Negative 3 times positive 6x is negative 18x equal to negative 7. Negative 2x minus 18x is negative 20x. And then I'm going to go ahead and subtract 33. Gives me negative 40. Divide by negative 20. So that tells me x is 2. And then you cannot forget to go back and plug it in. Now, I always go back and plug it into the equation that I've solved for because y is by itself. So if I plug that in, I get negative 11 plus 6 times 2, 12 minus 11, that tells me y is 1. So then my final answer, as an ordered pair, 2, 1. That tells me, remember, this is a way of solving it by graphing. That tells me that at the point 2, 1, these two graphs would intersect. That is the only solution. That also tells me there is only one solution because these two lines cross. So there is one intersection point. Next one is a little bit more involved because we don't have a variable by itself. There's really two ways that kind of stand out here. If I look at this bottom equation, everything is divisible by 3, so I could divide everything by 3 and then do substitution. I could also look and see that I have the same variable with the same coefficient, but I need to make it opposite signs. So in order to do that, we could technically, what we're doing, multiply everything by a negative 1, which if we do that to this second equation, we're going to get negative 3x minus 3y is equal to 3. You have to remember to multiply through on the opposite end as well. I'm just going to bring over my first equation equals negative 2. Then, for this sake, we're going to go ahead and we're going to do the second method, the elimination method, which means you always add down the columns. 3x plus negative 3x, those are gone. That's what you have to have in order for elimination to work. If they don't cancel, you didn't do it right. 4y minus 3y gives me 1y. Negative 2 plus 3 is 1. So I've solved for y this time. Now I go back, plug in my 1, and I will get x. So it doesn't matter at this point which one you plug it into. I'm just going to go back to this original. I could have plugged it into the 1 multiplied by negative 1. I could have plugged it in here. I just think this one's going to be the easiest. So 3x minus 3 is negative 3. I plugged in my negative 1. Add 3. So 3x is 0. That tells me x is 0. As an ordered pair, my final answer would be 0, 1. And that tells me that these two lines intersect at the point 0, 1. So let me move this down. We got one more. See if we can see that. Let's see if this will stay up on my board. There we go. Negative 2x plus 6y equals 6. Negative 7x plus 8y equals 5. Alright, so this guy is not divisible by anything. This one we could divide everything by 2. There's no way we could just multiply by negative 1. So I'm going to go through and do elimination, but a little bit tougher form of elimination. And this is not, I'm going to tell you guys right now, this is not the quickest way to solve this problem. My first thought would be to divide everything in the first equation by negative 2, then use substitution. That would probably be the quickest, but for the sake of review, I'm going to go through and solve it with elimination. So in order to eliminate, we have to have one variable that has the same coefficient with opposite signs. So in this problem, neither of them have the same variable already, neither of them have opposite signs, so it doesn't matter which one we pick. I'm going to eliminate x's. So that tells me I'm going to multiply the top by negative 7, and I'm going to multiply the bottom by positive 2. That's going to give me opposite signs, and they're both going to be 14. So negative 2x times negative 7 is 14x. 6y times negative 7 is negative 42y. And that's equal to negative 42. We get negative 14x plus 16y equal to negative 10. Add down. X's are gone. Negative 42 plus 16. Let's see. Oh my goodness. Oh good, it picked up. So then negative 42 plus 16 is going to give me negative 26y. Negative 42 minus 10 more is negative 52. Divide both sides by negative 26. Y is 2. Then plug it in. It does not matter which one of these four equations we plug it into. I always go back to the original just because they're smaller numbers. So negative 2x plus 12 is 6. Subtract 12, we get negative 2x is negative 6. Tells me x is 3. Remember, as an ordered pair, so we got the 0.32 is the solution to this system.